Have you ever tried to locate a buzzing fly in your room only to find it has somehow vanished when you look directly at it? Picture that for a moment. You know the fly is in the room, but the precise location seems to elude you, disappearing the moment you try to pinpoint it. This peculiar phenomenon, as mundane as it may seem, is a somewhat simplified gateway into the realm of the bizarre and the counterintuitive. Quantum mechanics. This elusive behavior of the fly is somewhat analogous to a fundamental principle in quantum mechanics, the Heisenberg uncertainty principle. In 1927, Werner Heisenberg proposed a theory that shook the foundations of physics. This theory, known as the Heisenberg uncertainty principle, challenges our understanding of the microscopic world. Think of it like trying to watch a fly buzzing about in a room. If you want to know exactly where the fly is, you'd have to make it stop. But then you wouldn't know how fast it was going or in what direction. On the other hand, if you want to know how fast the fly is going and in what direction, you'd have to let it buzz about. But then you wouldn't know exactly where it is at any given moment. Heisenberg proposed that the same principle applies to particles like electrons. You can't know both the exact position and momentum of a particle at the same time. The more accurately you measure one, the less accurately you can know the other. It's not a limitation of our measuring tools, but a fundamental aspect of nature. And it's not just about particles. This principle applies to everything in the universe, from the smallest atom to the largest galaxy. Everything has a certain degree of uncertainty, a certain degree of unpredictability. In other words, the universe has a built-in fuzziness, a sort of cosmic blur that governs the behavior of the tiniest particles. So, what does this principle mean for us and our understanding of the universe? The Heisenberg uncertainty principle, in essence, tells us that the act of measurement itself affects what we're trying to measure. This principle has profoundly reshaped our understanding of reality. It has introduced us to the peculiar and counterintuitive realm of quantum mechanics, a world where particles can exist in multiple places at once and can be entangled over vast distances. But more than that, the principle has challenged our everyday experiences and intuition. It's a far cry from the predictable world we perceive around us, where an apple will always fall straight down from a tree. The quantum world, on the other hand, is one of probabilities and uncertainties, where nothing is definite until observed. In the quantum world, nothing is certain until measured, and even then there's a limit to what we can know. That's the Heisenberg uncertainty principle for you, a testament to the beautifully mysterious world we live in.